Hi guys, so I'm just going to give you a quick rundown of some of the analytic geometry that you should know by now, I hope. Some of it was covered in the stuff I posted for Khan Academy last week and the CEMC stuff. So I'm going to go over the key things that you need to know how to calculate, and then we'll do a few examples relating to triangles. So midpoint, we talked about this quite a while ago now, like a month ago now. How to find the midpoint of a line. So it's a line segment. It cuts the line segment into two exactly equal pieces. So the midpoint is in the middle of that line segment, and it cuts it into two pieces that are equal. Perpendicular bisector goes through that midpoint of the line segment, and it is perpendicular, which means that it meets at a 90-degree angle, and it cuts it into two equal pieces like that. And you should remember the midpoint formula. It looks like this. You find the average of x1 and x2. So if this is x1 and y1, and this is x2 and y2, you find the average of both parts. So the average of the x values and the average of the y values, and that gives you your midpoint. Perpendicular bisector goes through that midpoint at a 90-degree angle, so you have to think about the slope. And if the slope is, let's say, 1/3, you need the negative reciprocal of that. So the perpendicular slope would be negative, and then you flip it upside down, so -3. Or let's say it was 11/3, the negative reciprocal would be -3/11. So the next things that you might have seen by now are the median and the altitude. So what the median does is it goes from one vertex of the triangle to the midpoint of the opposite side. So this midpoint cuts this side in half into two equal pieces, and the midpoint here joins up with the vertex that's opposite to it. So you can find the midpoint of any of the sides. You can cut this one into two equal pieces approximately here and join it up with this midpoint over here. And again for the other side. Whoops. Oh. There we go. Okay. Altitude. Altitude is also called the height. So when you've been calculating in the past, when you've calculated, say, the area of the triangle, you've been working with the base and the height meets at a 90-degree angle to the base. Well, that's actually called the altitude. So it goes from one vertex to the opposite side at a 90-degree angle. So again, we could have that on any of the sides. As long as it goes down and meets at a 90-degree angle, then that's the altitude. Next, we have the centers of a triangle. So there's actually 4 different centers. I'm only going to talk about 3 here. One of them that I'm not going to talk about is called the incenter, and it has to do with bisecting the angles. So you take any of the angles that are at the side and you cut them in half, but that is not relevant for what we're doing here. So I'm only going to talk about these 3. So the centroid, the orthocenter, and the circumcenter. The centroid takes all the medians, and it's where they intersect. So you take the median of this side, which is here. You take the median of this side here, and you take the median of this side here, and where they intersect is called the centroid. And the centroid is always going to be in the middle of the triangle somewhere on the inside. Some of the others, the orthocenter and the circumcenter, can be outside the triangle. This one will always be inside the triangle. Interesting fact here is that this is also the center of gravity of this triangle. So if you were to actually cut it out of paper or cardboard or metal or whatever, the centroid is where it would perfectly balance. The other thing that's cool is that the centroid is 2/3 of the way across the median. So this length here is exactly twice as long as this length over here. And same with this one. This is twice as long as this one. This is twice as long as this one. So it's 2/3 of the way across. So this is 2/3 and this is 1/3. So that's just some interesting stuff. So you take the medians and where they intersect. So if you know where 2 of the medians intersect, then you know where the centroid is, because all three of them will intersect at the same point. There's ways to prove this, but because we're in a tight time frame here, you're just going to trust me on this, or you can go look it up on YouTube or Google or whatever and find it for yourself. So the orthocenter is where all three altitudes intersect. So you take the altitude, the perpendicular height from each side, and where they intersect, you get the orthocenter. Now, it is possible for this one to be outside the triangle. So if you can picture an obtuse triangle, sometimes the orthocenter will be outside, and that's okay. So it's the intersection of the three altitudes. Then the circumcenter up here is the intersection of the three perpendicular bisectors of the triangle. So you take each of the sides, you find the midpoint, and then instead of joining the midpoint to the opposite vertex like you do for the centroid, you take the perpendicular bisector of that. So it has to meet at 90-degree angles from the midpoint. Do that with all three, and again, you get this thing called the circumcenter. And just like the centroid and the orthocenter, if you find where two of these special lines intersect, then that will be where the third one does as well. All three will always overlap. Interesting thing with this one is that if you circumscribe a circle around the triangle, and what that means is all the vertices of the triangle, all three of these, you draw a circle through those points, then this circumcenter is also the center of that circle, which means that it is perfectly equidistant from all three of the vertices. So it is also the radius of this circle over here. So no matter where you go on this circle that's out here, all of those will be exactly the same length. So I've put a link here that you can check out. It has nice clickable links where you can click on it, and it allows you to drag the triangles around and see what happens and see why these two could possibly be outside and this one will never be outside the triangle. All right, quick rundown of types of triangles. I hope this is like elementary school review here. You can classify triangles by the sides. So if all three sides are the same, you have an equilateral triangle. If two sides are the same, you have an isosceles triangle. And if all three sides are different, then you have a scalene triangle. You can also classify triangles by angles. So if it has a 90-degree angle, it's a right triangle. If one of the angles is greater than 90 degrees, it's an obtuse triangle. And if all three angles are smaller than 90, it's an acute triangle. It is possible to have an isosceles triangle that fits any of these. So you can have an isosceles right triangle. If the two that meet at 90 degrees are the same, then you have an isosceles right triangle. And same thing for an obtuse triangle. These could be the same. Or an acute one. Doesn't matter. Two of them could be the same. If it's an equilateral triangle, it will always be acute because each of these angles in here will be 60 degrees. Because there are 180 degrees in a triangle, you divide it by 3 because all the sides and angles are the same, and each of them is 60. And yeah, scalene could be right, acute, or obtuse. And one more slide here, types of quadrilaterals. Again, I really hope this is elementary review. A rectangle has two pairs of parallel sides, so this side and this side are parallel, this side and this side are parallel, and they all meet at 90 degrees. The ones that are parallel are also the same length. A square is a type of rectangle where all the sides are all the angles are 90 degrees and all the sides are the same length. Then we have a rhombus and a parallelogram. A parallelogram is like a rectangle that's been pushed over, so the opposite sides are parallel and the same length. They do not meet at 90 degrees. And then a rhombus is a type of parallelogram where all the sides are the same length. So it's like a square that's been pushed over. So keep in mind, a square is a rectangle and a rhombus is a parallelogram. It's just a special type of each one. A trapezoid has only two sides that are parallel, and then the other two can be at whatever angle. It is possible to have an isosceles trapezoid where these sides are parallel and these sides are the same. So this side and this side make it an isosceles trapezoid. Or if you're in the UK, you can call it a trapezium. And then a kite. Some people call this a diamond, but what it means is that the adjacent sides, so the ones that are touching each other, there's two pairs of adjacent sides that are equal. So these red ones are the same length and these blue ones are the same length. So for both the triangles, I put a link here with more information and where I got the graphic, and same thing here, more information and where I got the graphic. I'm going to stop it now and go to the other